Hello everyone. So let us start with new chapter, vector integration. So in this video we will see what is vector integration, its application and some problem based on vector integration. So first of all, the syllabus content is line integral, then work done, conservative vector field. Then after that we will see Green's theorem, then surface and volume integral, then Stokes theorem, and at last Gauss divergence theorem. So there are various applications of vector integration in engineering field. Uh, in terms of circulation, the Green's theorem convert the line integral to double integral of the microscopic circulation. Then similarly in water turbine and cyclone, uh, this vector integration is widely applicable. So these are some applications of vector integration in engineering. Then after that, let us start with our main content. So first of all we will see what is line integral. So line integral is nothing but single integral. Okay, and basically we are considering two type of line integral. First one is open integral and second one is closed integral. In short, there is difference between line integral and there is difference between open and closed integral is that the open integral is calculated or is measured over the point when the curve is straight line, okay, or parabola. When the curve is straight line or parabola, that is it is not closed, then we are applying open integral. For example, if we have circle or ellipse in the question or in the problem, okay, then we have to use the closed integral, and rest of the method to solve that integral is same, but we have to understand the difference between closed and open integral. And the closed integral is also known as counter integral. Okay, so let us move towards next. Okay, so here integration of f bar dot dr bar over c. Here the f bar is f1 I bar plus f2 j bar plus f3 k bar, and dr bar is equals to dx I bar plus dy j bar plus dz k bar. Okay, these are the vectors which can be written as in this form. Then the line integral, that is the multiplication of both f bar and dr bar, is given by integration over c f1 dx plus f2 dy plus f3 dz. That is integration, that is multiplication of two vectors. We will get this format where c is any curve. Okay, it is not mentioned it is parabolic or cubic or anything else. Okay, so here c is any curve. Now next concept is work done. So in vector integration, the work done is nothing but uh, integration of f bar dot dr bar or close integral of f bar dot dr bar. Then next one, the work done can be also find by using this formula, that is w is equals to scalar potential function from p to q. Now when to use this formula? Okay, so the condition is that if f bar is irrotational, okay, and the given curve is straight line, basically the given curve is straight line where we are applying this formula to find the work done. Okay, so this is an important condition. Now the important note is that if w is equals to 0, that is work done is equals to 0, then the given vector field is conservative field. Okay, if in problem it is mentioned the given vector field is conservative, then your work done will be always equals to 0. So let us start with first problem. Find the work done by the force F bar is equals to x square minus yz I bar plus y square minus zx j bar plus z square minus xy k bar in taking a particle from points 0 0 0 to 1 to 1. Okay, we have to find the work done, that is value of w, and the value of f bar is given, and we have to move particle from initial position, that is 0 0 0 to 1 to 1. So first of all, here it is clearly mentioned, we have to move particle from along a straight line na? And the equation is given, so we can apply this formula to find work done. Okay, you can also apply this formula to find the work done, but it is more easy to apply in this case. Okay, so first of all, we have to find whether the given vector field is irrotational or not. So we know that for irrotational, del cross f bar is equals to 0. So first of all, we will find the cross multiplication, that is cross product del cross f bar. So in determinant I bar j bar k bar, then dabba by dabba x, dabba by dabba y, dabba by dabba z, then respective terms, coefficient of I, j, k, and after uh, solving this determinant, we will get del cross f bar is equals to 0. So given vector field is irrotational. Now we have to find the value of scalar potential function, and after that by putting limit we can find work done. So similar formula is there of finding scalar potential as we are finding in vector differentiation. So phi is equals to integration of f1 dx plus f2 dy plus integration of f2 dy plus integration of f3 dz. So here all terms will be there, so all terms of x. Okay, then after that here the terms free from x. Okay, and here the terms free from xy. So after putting the values and calculating the integration, we will get phi is equals to x cube by 3 minus xyz plus y cube by 3 plus z cube by 3. Now finally we have to find work done. So we know that w is equals to 5 varying from p to q. The value of p, that is initial point, is 0 0 0, and the value of q is 1 to 1. So by putting upper limit and lower limit values and after simplifying, we will get w is equals to 4 by 3. So this is the work done in this problem. So let us move towards next problem. Find the work done by f bar is equals to 2xy square I bar plus 2x square y plus y j bar in taking a particle from 0 0 0 to 240 along the parabola y is equals to x square comma z equals to 0. So it is clearly mentioned we have to calculate along the parabola. So here we can't use the formula of w is equals to phi varying from p to q. So we have to clearly use the formula of first, and we know that parabola is open curve, so there is no closed integral here. So these are the some points you have to keep in mind. So by applying formula of work done, w is equals to integration over c f bar dot dr bar. Okay, so we will take value of f bar. Okay, then dot value of dr bar, and after taking the dot product we will get this. Okay, so here there is one condition is given, the value of z equals to 0. So we will uh, differentiate z, so dz is equals to 0. So by putting the value of z equals to 0 and dz equals to 0 in given equation, we will get this simplified equation where there is z and dz, then it will become 0. Okay, and after simplifying we will get this format. So now as we have given that the given curve c is parabola, so we will apply the equation of parabola y is equals to x square and differentiate. So dy is equals to 2x dx, and here uh, the limit is very important as we are calculating work done. So the x is varies from 0 to 2. Okay, and after putting the values of limit, that is integration from 0 to 2, okay, 2x x raised to 4 dx plus 2 x square plus x square into 2x dx, and after simplifying this we will get integration 6 x raised to 5 dx plus 2 x cube dx. X varies from 0 to 2, okay. You can also take convert this in terms of y, okay, but you can't take the limit in terms of z. Why we are taking x varies from 0 to 2? Because in a given problem it is clearly mentioned x is varies from initial position 0 to 2, okay. If you have to solve in terms of y, then you can take in terms of y also, and the limit will be y is vary from 0 to 4. But you can't take limits of z because the terms of z are 0 here, okay. Because it is clearly mentioned z equals to 0, and after differentiating we got dz is also equals to 0, so the terms of z are 0, so we can't take the limits of z. So either you can take x varies from 0 to 2, or you can take y varies from 0 to 4 with respect to changes. So after simplifying the integration we will get w is equals to 72. Now next problem is that evaluate integration f bar dot dr bar over c for f bar is given, okay, along the curve x equals to t square, y is equals to t, z equals to t cube, from t is equals to 0 to t is equals to 1. So here the curve is given in terms of time variable, okay. So we have, first of all we will write the given f bar, then after that we will take dot product of f bar and dr bar, and name that equation as equation number 1. Now coming to the curve, so now c is x equals to t square, y is equals to t, z equals to t cube. So we will differentiate this. Why we are differentiating? Because we have to replace the values of dx, dy, dz and all other terms in terms of t, okay. So here after putting that, now we have to find the limit of t. So here t is varies from 0 to 1, it is clearly mentioned in given question. So taking limit t varies from 0 to 1, and writing all other terms like x, y and z in terms of t, okay, by putting this value x is equals to t square, y is equals to t and z equals to t cube. And after simplifying all the given integration, you will get value is equals to 4 by 3. So it is simply integration, and you have to integrate and find the final answer. So these are the some problem, okay. So rest of the problem we will see in next lecture. Thank you.